Hey everyone, welcome to the last video in Module 8. This is 8-4, and we're going to be talking about mid-segments of triangles. You need to know that definition, mid-segment. That's a word that means a segment that connects the mid-points of two sides of a triangle. So every triangle has three mid-segments connecting two sides at a time. And mid-segments, as you can see here, are often used to add kind of sturdiness to structures. So we have like a porch garden swing in this picture, but we can also talk about relationships that we can discover between mid-segments and the rest of the triangle's measures. So that's what we're going to be exploring here. On page 396, the next page, we're going to be talking about describing mid-segments, again using the idea of coordinate geometry, putting the points on a coordinate plane. And you can see here in example 1, part A, we are showing that the given mid-segment of the triangle, so the mid-segment would be this line JK, is both parallel to the third side of the triangle, third side meaning the side that does not include the midpoints, so that would be GI. So is JK somehow parallel to GI? And also, is it half as long as the third side? It looks to be about half as long, but let's see if we can prove that with the geometry in the coordinate plane here. So the vertices that are given are -7, -1, -5, 5, and 1, 3. J, we're told, is the midpoint of side GH, and so we can calculate those points for GH. The midpoint is -7 plus -5 all over 2, or -6, and -1 plus +5 all over 2, or 2. So that's going to be point J. Let's go ahead and write those points on the coordinate plane just to kind of keep our work organized here. So that's -6, 2. Then we want to find the midpoint of the other side, IH, and we're going to call that K. So again, using the midpoint theorem, -5 plus 1 all over 2, and 5 plus 3 all over 2 gives me K has the point -2, 4. Okay, so we're going to see in step 2 whether the slopes of JK and GI are going to be equal, because if the slopes are equal, then we know that the sides are parallel. Or the segments are parallel, actually, we should say. Segments are parallel. Okay? So let's find the slope using our slope formula for JK. That is going to be 4 minus 2 all over -2 minus -6, or 2 over +4, or 1/2. Let's see if we can find the slope of GI. GI meaning this point right here, G and I, so that's going to be 3 minus -1 all over 1 minus -7, and there are our calculations, and again we get 4 over 8 in this case, but that does simplify to 1/2. So since the slopes are the same, the two segments are parallel. So that's the first thing. We were able to confirm, yep, those segments are parallel. The second thing we're confirming here in step 3 is the mid-segment JK half as long as the third side? Okay, so in step 3 that's what we're confirming. Let's move our page down a little bit. You can still see the graph. Okay, so for step 3, we are doing, to figure out the lengths, we're doing the distance formula. So here's our distance formula, kind of a blast from the past there. We have x2 minus x1 for JK, so x2 is -2 minus x1 is -6. And remember, we need to do that difference, and we need to square it, and then do the same thing with the y's. 4 minus 2, and get that all squared. So when we add those inside pieces of our square root up, we get +4 squared, or 16, plus 2 squared, which is 4, and so we get the square root of 20. putting that square root of 20 into simplified radical form, remember, with taking out the perfect square of 4 and leaving 5 underneath the radical, the square root of 4 simplifies to just 2 radical 5. Now we're going to do the same thing with the distance for g to I. So here's g and I, remember. We're going to do our x difference, so 1 minus negative 7 squared plus 3 minus negative 1 all squared, and that is going to be a positive 8 all squared, or 64, plus 4 squared, or 16, so that's the positive square root of 80, and the perfect square inside of that one, you guys, is 16 times 5 is the factor pairing, and of course the square root of 16 simplifies to 4, so we have 4 radical 5. And I hope you can see with these two values here, 2 radical 5 and 4 radical 5, that gi is twice as long, or jk is half as long as gi. That relationship kind of goes in both directions, but it is a 1 to 2 ratio for those sides. Okay? So on the next page, page 397, in part B, we're going to be doing the same process and filling in as we go here. We have a new triangle whose points are given here as 2, 7, 10, 9, and 8, 1, triangle LMN. And then we're told that P is the midpoint of LM and Q is the midpoint of MN. So let's do our midpoint theorem first off. Midpoint theorem for LM, these 2 points, we're going to do 2 plus 10 all over 7 plus 9. And then each of those divided by 2. So that gives me the point 6, 8. And so that's my point P. Let's go ahead and graph that point. 6, 8 is going to be right about there. And that's point P. The midpoint then of NM is going to be the same idea with the midpoint formula, 10 plus 8 all over 2. And 9 plus 1 all over 2, looking at the coordinates of these 2 points, averaged out, x's and y's, and that comes out to be 9, 5 is my point Q. Let's plot that point. 9, 5 is right about there. And so the question is segment PQ parallel to LN, and is it half the length of LN? Let's go ahead and first find the slope of PQ. So we're going to do here our 5 minus 8 all over 9 minus 6, fill in 6 there, and that comes out to be negative 3 over 3, or negative 1. And the slope of LN, going back to the original coordinates, L and N, would be 1 minus 7, the y coordinates difference, all over, subtracting in the same order, 8 minus 2, which is negative 6, all over 6, or also negative 1. So since the slopes are the same, we know that PQ and LN are parallel. We've proven the first thing that we need to prove. Now let's talk about, are the lengths in the same relationship? And again, we're going to use the distance formula. In step 3, we're doing the distance formula for PQ. PQ's distance, or PQ's coordinates, remember, are here and here. So it says something minus 6. We're going to be doing 9 minus 6 to figure out the difference in the x coordinates. And then 5 minus 8, all squared each one of those. We get 9 plus 9, or the square root of 18, or 3 radical 2 for our first distance for PQ. Our hope is that we're going to come out with maybe 6 radical 2 for the longer length LN. Let's see if we do. LN is going to be these points again, LN here. This time we want the difference of the x's and the difference of the y's to be squared. So we'll do 2 minus 8 all squared, and then that plus 7 minus 1 all squared. First difference squared is 36. second difference squared is also 36. So we get the square root of 72, which is the same thing if we broke out the perfect square factor of 36 there, is that we get 6 radical 2. So since 3 radical 2 is half of 6 radical 2, then we can say PQ is 1/2 of ln, and the length of PQ is half the length of ln. So we've proved it. In the last part of this video, you only have one problem to do here in the Your Turn section, and that is to prove, again, the two things that we were doing coordinate-wise, and that is that the mid-segment that joins points U and W is going to be half the length of the YZ side and also parallel to the YZ side. Notice you are not given the graph here, so make sure that you do that sketch first to kind of start making things all come together for you, okay? And we'll see you guys in the next video.